Hello class, let's look at these questions. Let's find the Z transforms of these signals. Okay, so here they are all standard signals. Okay, standard signals. So let's say is the Z transforms of standard signals. Okay, so these are Z transforms of standard what signals. So the first one is delta of what n. Delta of n. Delta of n is a unit impulse. Okay, you can call it unit impulse sequence or unit impulse signal. Okay, unit impulse what sequence. Delta of n. Alright, and then we also know that the Z transform of delta of what n is actually equals to what infinity, n equals to minus what infinity, Z of what n, and then here is what minus n, which is actually equals to infinity, n is equals to minus infinity. Okay, delta of what n into Z minus what n. But what is this unit impulse signal? The unit impulse signal is of this particular type. Okay, so here is what delta of what n, and then here is what n. All right, and then it occurs at this particular point. Here is what 0, and the value here, the magnitude is 1. So this is a unit what impulse sequence. So you see that it occurs at what 0 at a specific what instance of time. So we don't have to get a summation from minus infinity to what to infinity, because it occurs at what 0. Okay, so let's say here n is equals to what 0. If n is equals to 0, then what we can say is that the summation, okay, the summation here, delta of what n, here let me say, okay, infinity, n is equals to minus infinity, okay, Z minus what. So here, okay, the summation is not needed because it occurs at a specific instance of time, which is what n equals what 0. So I can say that delta of what n0, because it occurs at what 0 into this one. Okay, and ignore the summation because it occurs at a specific instance of what time, which is n equals to 0. Okay, and I know that delta of n is equals to what 1, because this place is equals to what 1. Okay, so the whole of this one is equals to what 1. Okay, it's equals to 1. So then what I can say is that the Z transform of delta of what n, okay, is actually equals to what 1. Or you can say that delta of what n into what here Z transform is what 1. All right, and then the ROC is the entire Z word plane. Okay, so this is the standard signal, which is what unit impulse signal. Now let's look at what II. II is a what? It's a unit. It's a unit step what sequence. Okay, so x of what n is equals to z of n is equals to what u. Okay, is equals to u of what n. Okay, is equals to u of n. Okay, so u of n here is a unit what step sequence. Okay, step sequence, or you can even say signal, but you have to be mindful that it is different from a continuous step signal. This is a discrete time what signal. All right, so to differentiate it from discrete, from continuous time signal, normally we will use the term sequence, but it's also a signal too. Okay, so here u of what? N. So here, what we can say is that x of what? Z is equals to summation minus infinity, n equals minus infinity to what? Infinity. X of what? N to what? Z minus n. So this is equals to what? So let's plot the unit step sequence here. Okay. So the unit step sequence here, okay, here is like this, like this, like this, like this, okay. Here is what? N. Value is what? 1. Here is u of what? N. It continues to infinity. Here is 0, 1, 2, what? 3. Because u of n means that n is equal to 0. It's starting from what? 0 to what? Infinity. So this is a unit step what? Sequence. Okay, it's a unit step sequence. So it's starting from 0 to what? Here is what? Infinity. It's going to what? Infinity. Okay, it's going to infinity. So now, if you should put your this thing inside, then you're going to have what? You're going to have n is equals to what? 0. And then it's equals to what? Infinity. Okay, here u of what? U of n. Okay, into z minus what? N. But n is what? What is the value for n? N is what? 1. Okay, but u of n is equals to what? 1. Because this place you can say the value is what? 1. Okay, so in that case, my summation now becomes n is equals to 0 and is equals to what? Infinity. So this place I'll put 1 there. If I put 1 there, then it will become what? Like this. Okay. Now what can I do? What I can do from now is that I can introduce my limit. Okay. I can introduce my limit. So here, if I am introducing the limit into this one, okay, if I'm introducing the limit, then what is going to happen is that if I put 0 here, n is equals to what? 0. Okay, and then, so if I put 0 here, what will happen? Every number exponent 0 is what? Is 1. So I'll get to 1. If I put 2 here, from 0 I go to 1. If I put 1 here, what do I get? This is what I will get. If I put 2 here, 2 inside this one, what do I get? I'll get, this is what I'll get. Z exponent minus 1. Okay. Because actually this function, okay, I can rewrite this function in this particular manner. Okay. I can write it in this particular manner. That's summation up to what? Infinity. N is equals to what? 0. I can rewrite this function as z of minus what? 1 into what? N. Okay, I can rewrite this function as this. Okay, so if I put 2 inside, then I'm going to get what? Z minus what? 1 into what? 2. Plus if I put 3 inside, I'll get this one. Okay, plus it goes on to what? Infinity, because you can see that your function here is going to what? Infinity. Okay, so this will be the what? The summation. Okay, so this will be the summation. So now what I can do is, okay, so to continue from there, what I can say is that let x to be equals to what? Let x to be equal to z exponent minus what? 1. If I do that, then I'll get what? 1 plus what? X plus what? S squared plus what? X cubed plus what? Up to infinity. Okay. And then already we know that when we have any series like this one, then the binomial expansion is 1 minus what? X. Here, okay, x of what? Z. Here, x of what? Z. Okay, in exponent what? Minus 1. Okay, so this is the expansion that gives this particular series of 1 plus what? X plus what? S squared plus what? S cubed plus what? Up to infinity. Okay, so this is the sequence that gives that a series. Okay, so now I told you that whenever you have a series like this one, then x is supposed to be less than 1, else it will not converge. Okay, if it's less than 1, then it will converge what? Below infinity. If it is more than 1, then it will converge at what? Infinity. But in the ROC, we want that the convergence to be what? To be below what? Infinity. Okay, to be below what? Infinity. Okay, it should be below what? Infinity. So here, that means that x must be less than what? 1. Okay, if x is less than 1, then what it means is that z inverse should be less than what? 1, which means that 1 over what? Z should be less than what? 1, which means that 1 is greater than what? Z, or Z is less than what? 1. Okay, so basically this becomes our ROC. Okay, this becomes our ROC. Okay, this becomes our ROC. All right, so let's see. Please, let's check something here. You see that x is less than what? 1. X inverse, Z inverse is less than what? 1, because I said that x is equal to what? Z inverse. So here, 1 over Z, okay, is less than what? Is less than 1. Is less than 1. Okay, now if Z goes here, then it will become what? Okay, it will become this way. 1 is less than what? Z. Sorry, okay. 1 is less than Z. Okay, and here also, it will become the same thing. Okay, Z is greater than what? 1. Okay, you can just follow what I have written here. You will understand why I'm getting this. Okay, so x is less than 1. Okay, so now x is what? Z inverse. So Z is inverse is less than what? 1. Now 1 over Z is less than what? 1. Now if Z goes here, then what you can is that Z is not greater than what? 1, and Z is greater than what? 1. Okay, so that is how it is like. Okay, so now let's finish with the Z transform. So now the Z transform is going to be such that it's equals to 1 minus x minus what? 1, where we reached. Okay, so now if we have this one, then it's equals to what? 1 over what? 1 over 1 minus what? X, which is equals to 1 over what? 1 minus Z what? Inverse. Okay, which is equals to, if I should multiply through by Z, okay, then basically, if I multiply through by Z, I'll have Z here, I'll have what? Z here, and then I'll have minus 1 here. Okay, so this becomes the Z transform. So now the Z transform, okay, the Z transform is now the Z transform. Sorry, let me say equals, the Z transform is now equals to what? Z over what? Z minus 1. Or much better still, what I can say is that if you have a unit step what? Sequence, okay, and then it goes through what? Z transform, then you're going to get Z over Z minus what? 1. And then your ROC is going to be what? Z mod Z greater than what? 1. Okay, so that is how you can solve this one. Okay, now let's go to the next one, which is what? I, the third one. Okay, so the third one, okay, we are what? Giving x, we are giving x of what? N is equals to n u of what? N. Okay, this one is a unit, is a ramp sequence. Okay, it's a ramp sequence. Okay, so this one is a ramp sequence. Okay, but here we can also call it here ramp sequence. Also, you will consider it as unit ramp. Okay, sequence. Okay, unit ramp sequence. Okay, unit means 1. Okay, all right, so basically here, let's consider this unit ramp sequence. All right, so now let's denote how it is like. U of n means that n is equals to what? 0. And the ramp sequence is like this. Okay, n is equal to 0, meaning that we will start from what? 0. Okay, we will start from what? 0. Okay, so here n u of what? N. So we will start from 0. So then here is 0. Here is 1. Here is 2. Here is 3. It goes to what? Infinity. It goes to what? Infinity. Here is what? N. Okay, so this is the unit ramp what? Sequence. Okay, now with respect to the z transform, x of what? N, x of z, okay, is equals to what? Summation from what? Infinity. N is equals to minus what? Infinity. X of what? N into z minus what? N. Okay, so now here I'll have what? It's from 0 to infinity. So n is equals to what? 0 is equals to what? Infinity. Okay, so here I'll have what? I'll have n u of what? N into z minus what? N. This is what I will have here. Okay, this is what I will have here. Okay, so now what I can say is that u of n is what? Is 1. So let me rewrite it here. It's what? Summation infinity. N is equals to what? 0. N u of what? N. Into what? Into z minus what? N. You see that n here is u of n. U of n is what? It's a unit step sequence. And the value for unit step sequence is always what? 1. So if I put 1 into this place, into the u of n, then I'm going to get summation here, infinity. N is equals to what? 0. N, this n is here, so this place is 1. So z minus what? N. So this is what I am going to what? Get. Okay. So now, if I have this one, then you should know that I can actually rewrite this one. This one, I can rewrite it as what? Infinity. N is equals to what? 0. Okay. And then what I can have is, I can have n out, z minus what? 1 into what? N. Okay, into n. And then what I can have from here is that I can have the expansion for this particular series. I can have the expansion for this particular series. Okay, so let's say n is equals to 0. If n is 0, this whole function will go to 0, because if 0 is here, the whole function will go to 0. Okay, so we will not mind that. What about if n is 1? Okay, so now if n is 1, then what is going to happen is that we're going to have z inverse. Okay, we're going to have z inverse. Okay, if n is what? 2. If n is 2, then we're going to have what? Plus 2. Okay, we're going to have plus what? 2, because here is 2. Here is 2. And then we're going to have this one. Okay, z minus what? 1. And here will be 2. Okay, if n is 3, we're going to have what? 3. Here will become 3. And then we're going to have what? Z minus 1. And here will be what? 3. Okay, so we continue that up to what? Up to infinity. Up to infinity. So now I can say that let z inverse to be equals to what? X. Okay, if I do that, then I'm going to have what? I'm going to have x plus wait a minute. Before I let that one to be x, please wait a minute. Let me do some further simplification, okay, so that I can actually simplify my stuff more, okay. So now let me say that I'll bring out z inverse what? Out. If I bring z inverse out, I'll have 1, okay, I'll have 1. And then here, what am I going to have here? Okay, here, basically, I'm going to have what? I'm going to have, what I can have here is, I can have z inverse, wait, let me see. Okay, so in that case, what I'm going to have here is, checking it, if this guy comes out, this place, I'll actually be left with 2z inverse. So that, you see that when you multiply here, you get what? Z exponent minus 2, this place, if you multiply, you get z exponent minus 2. Now here too, if you multiply here and here, you get z exponent what? Minus 2, so it's correct. Then plus what? Plus 3, okay, plus 3, okay. So 3, what will I get? Z inverse minus what? 1, Okay, z inverse minus 1. And then, but if I do, I will not really get it. Okay, so now what I can do is I can bring square here. Okay, I can bring square here. Now if I do, I'm going to actually have it. Okay, how? Because now here, this place, I'll get exponent minus 3. Now here, this place will give me exponent minus 2. If I multiply by here, I'll get minus 3. So I'll continue like this up to infinity. Okay, so now let x to be equals to z inverse. Okay, if x is equals to z inverse, then what I will get here is x of z. Okay, is now going to be equals to it's now actually going to be equals to, here what you can see is that, okay, it will be equals to z exponent minus 1. Okay, and this particular series that we have here, okay, this particular series that we have here, okay, so I can say that 1, okay, plus 2x, that is if x is equal to inverse of minus 1, okay, 2x plus 3 s squared, okay, 3s squared plus up to infinity. Okay, so this is what I will get. Now if you have this particular series, okay, then its binomial expansion is 1 minus x into minus 2. Okay, so that is what will give you 1 plus 2x plus 3s squared plus up to infinity. So now if I should bring that one here, then I'm going to get x of x of z is now equals to z inverse. Okay, z inverse into 1 minus x exponent minus 2. Okay, now this is what I'm actually going to have. Okay, so now if I have this one, then to go further, let's move on from here, turn our sheet over. Okay, so now continuing from there, okay, from where we turn our sheet over, then we're going to have x, okay, we're going to have x, okay, of z to be equals to x of z to be equals to to be equals to, here, what we're going to have is, we're going to actually have, let's see what we got the last time. Okay, so the last time, this is what we had. Okay, this is what we had. And what we had here the last time, actually, it is equals to, what? It is equals to z inverse, okay, into what? 1 over what? Z inverse into 1 over what? 1 minus what? X, okay, all squared. Okay, it's equals to this. Okay, so now if we have this one, then let's move on from here. Okay, so now continuing from there, we are actually going to have, okay, we are actually going to have here z inverse into what? Into 1, okay, into 1 over what? 1 here, okay, minus what? X. What is x? X is what? Actually z inverse. Okay, actually z inverse. Okay, and then here is what? Squared. Okay, here is squared. Okay, so basically this is what we're going to have. Okay, so now if we have anything like this one, what we can do is that we can even multiply through by z. Okay, we can multiply through by z. Okay, so now, or we can multiply through by, okay, let's say multiply through by z squared. I think it's better to multiply through by z squared. If we multiply through by z squared, then here we will have what? Z over here. We will have z over here. And then here we actually going to have z minus what? 1 all squared. So if I do that, I'm going to have what? Z over what? Z minus what? 1 or what? squared. Okay, so now this becomes what? The Z transform for this one. Then what about the what? ROC. So the ROC, we know that we got what? X is supposed to be less than what? 1. Okay, for that particular series. If not less than 1, then it should run to what? Infinity. So ROC. Okay, so now this one is equals to 1 over what? Z. Okay, it's equals to 1 over Z, which is actually what? Less than what? 1, which is actually less than 1. So now here I'm going to have what? Z is greater than what? 1. Okay, so I'll have what? Z greater than 1. Okay, so because it's ROC, I'll make it what? Mod Z. So now I'm going to have n unit ramp signal, n u of what? N has a Z what? Transform of Z over what? Z minus 1 squared. Okay, and then the ROC, okay, the ROC is such that mod Z is greater than what? 1. Okay, so basically this is the end of this particular question. Let's go to the next one, which is number 4. So number 4, we have IV, and we are given x of what? N to be equals to sine, okay, sine omega naught what? N into what? U of what? N. So U of N is a unit step sequence, okay, unit step sequence. Okay, it's telling us where our signal will begin. Okay, and U of N means that N is equals to 0. So basically, this particular signal is a discrete signal. So we're going to have sinusoidal. Okay, so something like this. Okay, something like this. Okay, so we're going to have something like this, something like this, something like this. Okay. Okay, so so this is how this sinusoidal signal, which is a discrete signal, will actually what look like. Okay, this is how it will look like. Okay, so the unit step n is equal to 0 means that it will start from what? 0. Okay, all right. So here you have what? Sine what? Omega naught what? N into u of what? N, and here is what? N. All right. So now if we have this one, then what can we do? Okay, very simple. So the sine, okay, whenever you have sine, sine omega naught n is actually equals to e j omega naught what? N, okay, minus e, okay, minus j omega naught what? N, okay, over what? Over 2j, okay, over 2j. Always remember this expression. Okay, in my previous classes, I showed you why this particular signal gives this what expression. I think in Laplace transform I showed you. So please, you can visit that one to know why this signal is giving us what this expression. Okay, why it's giving us this expression. All right. So it's not too difficult. You can just refer to my class in signals and systems, and you'll be able to know that. Okay. So now, here, what we're going to right now do is that we're going to have, I'm just trying to look for something so that I can actually show you why that signal is actually like that. Okay, so now, just see here. Okay, so now we have what? Whenever you have e j omega naught n, okay, minus what? E j omega naught n. Okay, here is minus. Okay, so what does this one mean? This one over what? 2j is equals to what? Sine omega naught what? N. Okay, so what does this one mean? This one means that cos what? Omega naught, okay, let's say cos omega naught n, okay, plus sine omega naught what? N. You put j here. Okay, so this one, what it means is that you're going to have minus, okay? You're going to have minus. Cos omega naught what? N, okay, minus, okay, what's here is minus, okay, j sine omega naught what? N. So now you see that if you multiply, if this negative should multiply through, then this and this will cancel each other. This and this will cancel each other. If it should multiply through, then this one become what? Positive, because this time this will make this guy positive. So now we're going to get what? 2j sine what? Omega naught what? N. Okay, 2j sine omega naught n. So now if we have 2j sine omega naught n, and then what are we looking for? We are looking for sine omega naught what? N. So if we divide here by what? 2j, then this one will cancel this one. Okay, so now you see why they are giving this way. Okay, so if you divide it by the 2j and there's 2j here, okay, this is what you get. All right, so it's that simple. Just follow it. Okay, so now knowing that we can just move on directly. Okay, so now here I can have u of what? N. Okay, so if I should put it into the sequence, then I'm going to have x of what? N is x of z, z transform. Okay, so here, see, I'm starting from 0, and here is going to what? Infinity. So summation from what? Up to infinity, n is equals to what? 0, because it's starting from 0. Okay, so now what I can actually do here is that I can have here ej omega naught n minus e minus j omega naught what? N. Okay, over what? Over 2j. Okay, into u of what? N. Okay, so this is what I can have here. So now, if I have this one, then what can I do? Okay, you see that basically, into z of minus what? N. Into z of minus n. Okay, so now here it becomes what? E of z is equals to what? Here, n is equals to what? 0. Okay, so I can have what? I can have like this. Okay, I can have ej omega naught what? N. Okay, ej omega naught n. Okay, please let me write it again. Okay, so what can I have? I can have x of what? Z is equals to summation, here infinity, n is equals to what? 0. Okay, I can have 1 over 2j can come out, 1 over 2j can come out, and then I can have what? Here I can have e j omega naught what? N into z minus what? Into z minus what? N. Okay, u of n is 1. Is 1. So unit step signal, I can what? Ignore it. Okay, minus what? The second aspect, which is what? E minus j omega naught what? N. Okay, into what? Z minus what? N. Okay, so this is what you can have. Alright, so this is what you can have. Now, if you have this one, then I have to apply, if I should apply Z transform, if I should find the Z transform of this one, and then the Z transform of this one, okay, for the Z transform of this one, you know that I'm going to get, what I'm going to get is that I will actually have 1 over what? Z minus this one. Okay, so x of what? Z, okay, is equals to expand this one, okay, 1 over what? 2j, okay, into what? 1 over z minus what? E, okay, j omega naught what? N, for the first one, okay. Then here, I'm going to have minus, okay, minus what? 1 over what? Z minus E minus J omega naught what? N. Okay, so for this particular one, okay. So basically that is how it's going to behave. Okay, so that is how it's going to behave. Okay, so basically that's how it will behave. And then one thing is that whenever you have Ej omega naught n, the value is 1. Okay, the value is 1. Okay, because what we know is that if you have Ej omega naught n, it is actually equals what? Cos omega naught n plus sine what? Omega naught what? N. And cos omega naught n plus sine omega naught n gives what? 1. Okay, so here our value here is 1. Okay, in that case, our ROC, okay, in that case, our ROC is going to be what? It's going to be greater than what? 1. So now our ROC mod Z is going to be greater than what? 1. That will be our what? Mod Z. Okay, that will be our mod Z. All right. Because you can just remember that whenever we had 1 Z over, okay, let's say Z, or okay, whenever we had, let's say 1 over Z minus 1, okay, our ROC, okay, is such that Z is greater than what? 1, okay. So here, similarly, our ROC, our final ROC, Z greater than 1, that's one ROC. Our second one will be the same, okay, Z greater than what? 1, because they're almost the same. And then our final ROC, okay, let's say here, final ROC, okay, will be what? Z greater than what? 1, okay. So basically, this is how you can find the Z transform for this one, okay. That's how you can find the Z transform for this one, okay. So here you have the 2J what? Outside. So now you can even simplify it further. So if you want to simplify it further, you can see that x of Z is equals to what? If you should take this one what? Up, and you take this one also up, okay, you're going to have what you're going to have is that you can have here, if this guy should come up and this guy should come up, okay, I'll have here Z minus E minus J omega naught what? N, okay, and then I'll have minus, okay, and then I'm going to have minus Z, okay, I'm going to have minus Z, but here it will be what? Plus E exponent plus what? E exponent what? J omega naught what? N, okay. So basically this is what I'm going to have here, okay, all over what? All over Z minus what? E J omega naught what? N, okay, into what? Z minus E J omega naught what? N, but here this place is minus like this, okay. So let me rewrite it well for you, okay. Let me rewrite it well for you. So now to rewrite this one well for you, what I'm actually going to get is that I'll have x of what? Z to be equals to, okay, here like this. So Z minus E minus J omega naught N, okay, minus Z plus E J, okay, E J, okay, omega naught what? N, okay, so like this. Okay. Then here I'll have Z minus E J omega naught N, okay, into what? Z minus E minus J omega naught what? N, all right. Okay, please, let's check here, okay. If we have the Fourier transform of this one, if you're looking for the Fourier transform of something like what? If you're looking for Fourier transform of what? E J naught what? This one, okay, into Z minus N, okay, it's going to be equal to what? Z over what? Z minus, because here is plus, okay, E J omega naught what? N, okay, because remember that when we were looking for what? A U of what? N, what did we get? We got what? Z over what? Z minus what? A, all right. That was our Laplace transform. That was our Z transform. So if you're looking for the Z transform of this one, it's supposed to be what? Like this, okay. So now here I'm supposed to bring what? Z here, okay, for the Z transform for this one, supposed to be Z here, and the Z transform of this one, I'm supposed to bring what? Z here, okay, supposed to bring Z here. So now I'll basically have my what? If I bring my Z out, then I'll have Z over what? 2J, okay. Then I'll still have what? Z over what? 2J, okay. So that is what I'll have, okay. That is what I'm going to have, all right. Okay, so that's what I'll have. Okay, so now moving on from there, we're going to have, okay, so now moving on from there, we are going to actually have Z out 2J, okay, Z out 2J. So now, what do we have? Z out. X of what? Z is equals to this. Okay, we're going to have Z minus, okay, E minus J omega naught N. Alright, minus Z plus E J omega naught what? N. Okay, so this is what we're going to have. Alright, so now here I'm going to have Z minus E J omega naught what? N. Okay, then I'll have Z minus E J omega naught N. Here is minus, okay, like this. So now this one will actually cancel what? This one. Okay, this one will cancel this one. Okay, and then what will I have? So I'll be left with what? Z over what? 2J into what? Into EJ omega naught what? N. Okay, minus EJ, yes, minus omega naught what? N. Okay, over what? Over Z over Z squared. Okay, Z squared into here, I'll get what? Z into Z. And then this guy into this guy into this guy, this guy into what? This guy into this guy, okay, and then this guy into what? This guy, okay. So basically, I'll have plus Z out, okay. I'll have minus Z out, okay, because this guy into this guy will give me negative. This guy into this guy will give me negative. So it's better to bring a negative out. And I'll have Z. Okay, so into this guy first. Okay. No, into this guy into this guy first. Okay. So that means that I'll basically have E J omega naught N. Okay. E J omega naught N plus E J omega naught what? N. Okay. Yeah. So let me see this. Okay, so now I can just bring here negative. Okay, and then what will I have again? Okay, what will I have again? I'm going to have this guy into this guy. Okay, this guy into this guy. Basically, whenever you have EJ omega naught N, I told you that it gives what? 1, and then minus minus, it will be what? Positive, so plus 1. Okay, so let me rewrite it again. I'll have what? 2J into here EJ omega naught N minus E minus omega naught what? N. Okay, into what? Z squared minus Z. Okay, Z squared minus Z into what? EJ omega naught N plus E minus J omega naught what? N. Okay, plus what? 1. Alright, so this is what I have. Now here, Z over what? 2J. Okay, this one I told you before is what? It's going to be what? 2J. It's going to be what? 2J sine omega naught N. If you do the expansion like I did before, okay, and then here it's going to be what? Z squared minus what? Z. This one is going to give you what? Cos omega naught N. Okay, it's going to give you cos omega naught N. You can just briefly you can just see it that if you have this one, then you're going to have what? This one, okay, this part is going to give you cos omega naught N, okay, plus J sine omega naught what? N. Then you come here, this place, it will give you plus cos omega naught what? N, okay, minus J sine omega naught what? N. Okay, so this one will cancel what? This one. You'll be left with what? Cos omega naught what? N. But it will be 2 cos because one cos, another cos. So it will be what? 2 cos omega naught N. Alright. So now here I'll have minus Z. So I'll have minus 2Z. Okay, cos omega naught what? N. Okay, plus 1. Okay, plus 1. Okay. The one I told you that if this one multiply this one, okay, this one, whenever you have this one, is what? 1. I've shown you. And this one, if you have this one also, is what? 1. So 1 times 1 is what? 1. And then negative, it also be what? Positive. So you have what? Plus 1 here. So this is what you get. So now 2J will cancel what? 2J. and then you're going to have z sine. So x of what? Z is equals to what? Z sine omega naught what? N. Okay, over what? Z squared minus 2z cos omega naught n plus what? 1. Okay, so basically that is what you're going to get. Okay, that is what you're going to have. Okay, so now what I can say right now is that if you have the Fourier, if you're looking for the Z transform, okay, if you're looking for the Z transform for, let's say you have sine omega naught what? N, okay, u of n, and you want its Z what? Transform, then it's supposed to be what? Z into what? Sine omega naught what? N over what? Z squared minus 2z cos omega naught what? N plus 1. Okay, and then your ROC is going to be greater than what? 1. All right, so that is what you get for this one. Now we will go to the final aspect of this one, okay, which is going to be this one, okay, given what? Let me try and look at a question before. Okay, let's see how it's going to be like. Okay, so given, I'm trying to see the question. I've forgotten the question because you have been doing plenty. Okay, you have been doing plenty. Okay, so we just finished with sine omega naught n. Okay, so let's do the next one, which is what? Given what? Given I've even forgotten the question number. Given what? X of n. Okay, given x of n to be equals to what? Cos omega naught what? N. Okay, to be equals to cos omega naught n. So now here we know that cos omega naught what? N is equals to what? E j omega naught what? N. Okay, plus E minus j omega naught what? N. Okay, so that is what we're going to actually what? Have. Okay, actually have. All right, I think it's supposed to be over 2. Okay, over 2. Let us check and see. That's what I think. Okay, let's check and see. So to be able to check for this one, what you're going to do is that you're going to have here, this one is equals to what? Cos omega naught what? N. Okay, plus j sine omega naught what? Sine omega naught what? N. Okay, plus cos omega naught what? N. Okay, minus j sine omega naught what? N. So this one and this one will cancel each other. So you have what? 2 cos omega naught what? N. If you have 2 here, then you must divide it by 2 so that you'll cancel out, and you get what? Cos omega naught what? N. Okay, so I think it's supposed to be what? 2 here. Okay, so now if we should actually put this one into our series, then we're going to have here x of what? Z is equals to n equals to what? Minus what? Infinity. Okay, up to what? Infinity. And what do we get here? Okay, so here we are going to have ej omega naught, okay, plus e minus j omega what? Naught what? N. Okay, into what? Z minus n over what? 2. Okay, so this is what we're going to get. So now if we have this one, to write it properly, I can say that here, okay, n, if I should put in my unit step sequence, you see that is what? Cos omega naught what? Here is u of n, meaning that it is starting from what? 0. So I'll put here to be 0, I'll put here to be infinity. Okay, then here e j omega naught what? N. Okay, plus e minus j omega naught what? N. Okay, so here over what? 2. Okay, over 2 into what? U of what? N into what? Z minus what? 1. Okay, but I know that u of n is what? 1. Okay, so now if I should put 1 into that particular space, then what I'm going to have is going to be a little bit, this is going to go away. Okay, so if that one should go away, then what I will have is going to be like this. Okay, it's going to be like this. Okay, so basically I'm going to have okay, so basically what I'm going to have is I'm going to have here x of what? Z is equals to here infinity, n is equals to what? 0. Okay, here I'm going to have e j omega naught n, okay, plus e minus j omega naught what? N, okay, over what? 2 into what? Into z minus what? N. Okay, so this is what I'm going to have. So now if I should take this aspect differently, so now if I should say that okay, summation here n is equals to what? 0. Okay, here what I'm going to have is, let's say I have e j omega naught what? N into z minus n. Okay, so let me bring 1 over 2. I can bring 1 over 2 here. Okay, plus e minus j omega naught what? N. Okay, into z minus what? N. All right. Okay, so now if I have this one, then what am I going to get? And then x of z is equals to what? Z transform of this one. So 1 over 2. Z transform of this one. Z transform of this one is going to what? Z over, is going to be Z over what? Z minus e j omega naught what? N. Okay, plus what? Z over what? Z minus what? E minus j omega naught what? N. Okay, so this is what I'm going to have. All right, so that's what I'm going to have. Okay, so now you can just bring your z out. So now x of z is equals to 1 over 2 into what? Z. Okay, here you have what? 1 over what? Z minus e j omega naught n. Okay, plus what? 1 over what? Z minus what? E j omega naught what? N. All right, so this is what you have. All right, so now if you have this, then you have what? X of z, okay, to be what? To be equals to z over 2. Okay, z over 2 into what? 1 over z minus e j omega naught n plus 1 over z minus e, yes, minus e, okay, minus j omega naught n. Okay, so basically this becomes what? Your z transform. This becomes your z transform. Now, before we simplify our z transform further, we can find our ROC. So what is going to be our ROC? So here, if you should find ROC for this place, this one, we told you that is 1. The magnitude is what? 1. Okay, the magnitude, you can follow mine, the earlier one we did. Okay, here the magnitude is what? 1. Okay, so now it's going to be what? It's going to be mod z, which is greater than what? 1. Okay, and here also, and here is going to be what? Mod z, which is greater than what? 1. Okay, so now the final ROC will be just one of this one. Okay, it will be what? Z greater than what? 1. Okay, so that will be the what? The ROC for this one. Okay, so now here to simplify further, I can say that x of what? Z is equals to here z over what? 2 into what? Into this one can come up. This one can come here. So it will become what? Z. It will become what? Z over. Oh, sorry. Okay. So it will become what? Z minus e j omega naught what? N. Okay, minus here. Okay. So plus here z minus e j omega naught what? N. Okay, and then here I'm going to have z minus e j omega naught what? N into what? Z minus e j omega naught what? N. Okay, here is minus. Okay, so this is what I'm going to have. Okay, so now if I should multiply through, then I'm going to have z over 2. Z z over 2 into what? 2z, okay, into 2z. And then here I'm going to have this one, and then I'm going to have this one, okay. So then I'll have here I'll have 2z, okay. I'm going to have 2z into what? 2z into here, this plus this, okay. And then I'm going to have this into this plus this also plus this one, okay. All right, so now that one I can just bring one minus 1 out. Then here I can have e, okay, j omega naught n, okay, plus e minus j omega naught what n, okay. So this is how I can actually do it, okay. So now it's going to be all over, okay. I'm going to have what? Z squared, okay. So I'll have z squared, and then I'm going to have this into this, okay, and then this into this, okay. So that means that I'm going to have minus z out, I'm going to have here, okay, if I bring z out, I'm going to have e j omega naught n plus e minus j omega naught what n, okay. Then this into this will give me what? 1. Minus minus will be what? Plus 1. So it will be what? Plus 1. Okay. So now if I have this one, then what I can say is that z over 2 is into, basically this one is what? This one is supposed to give me a cos. Okay. It's supposed to give me a cos. Okay. So that means that I will have 2z minus cos omega naught what? N. Okay. Over what? Over here is what? Z squared. Here is supposed to give me a cos, okay. It's supposed to give me a cos, okay. But a cos here, it will give me a cos, but it will what? Minus 2 cos. Here also it will give me minus 2 cos, okay. So 2z what? Cos omega naught what? N plus what? 1, okay. So basically this is what I'm going to get, okay. This is what I'm going to get, okay. So now here you can cancel these two and then this one, and then I'll be left with what? X of z, okay, to be equals to what? Z into, okay, z into here I'll be left with what? Z minus 2 cos what? Omega naught n, because these two will cancel these two, okay, over what? Over z squared minus 2z cos omega naught n plus what? 1, okay. So this is what I'm going to get. So now what I can say is that whenever you have cos omega naught n into u of n, you are actually supposed to get, for your z transform, you should get z into z minus 2 cos omega naught n over z squared minus 2 cos omega naught n plus 1, okay. So this is what you're supposed to get, okay. Now I think there are just a few in this particular series which we have to go for. I think there are quite a few, okay. I think 4 and 5. I have not solved 4 and 5. So briefly, let me just finish off with the what? 4 and 5. I think they are very simple that we can just deal with. Okay. So I think we have in the among the questions we are given z of n to be equals to what? Z of n to be equals to what? E minus j omega naught n into u of what? N. I think this is very simple. So now here, x of what? Z is equals to summation infinity, n is equals to minus what? Infinity. X of what? N is equal into what? Z minus what? N is equals to what? U of n means that the unit step is starting from what? 0. So now I have here infinity, n is equals to what? 0 into x of what? N into what? Z exponent minus n. Okay, so now here what I will have is I'm going to have x of what? Z to be equals to summation, n is equals to 0, and then here is infinity, and then here is e minus j omega naught what? N into what? U of what? N into Z minus what? N. So now here, unit step is 1. So if you should introduce a 1 there, then you will get infinity, n is equals to what? 0. And then you're going to have e minus j omega naught n. Here is 1, so it goes away, it becomes minus what? 1. So now if you have a sequence like this, a function like this, and you want the Z transform of this one, okay, then you should know that you're supposed to actually get, so now here is supposed to be Z transform. So now the Z transform, okay, is supposed to be equals to what? Z over what? Z minus what I have here, E minus J omega naught what? N. Okay, so this is supposed to be the Z transform, okay, the Z transform for this particular one, all right. Okay, so this is supposed to be Z transform. And then our ROC, okay, so now our ROC is going to be what? Mod Z. Okay, this one, the value is 1, okay, is greater than what? 1. Okay, so that's how you solve it. So now also, given this one also, you're giving x of n to be equals to e j, we got, here is positive, n into u of what? N, okay. So here, this place is what? It's starting from 0, okay. So we can see that x of what? Z is actually equals to what? It's starting from 0, so n is equals to 0 to what? Infinity, okay. Then we're going to actually have e, okay, j omega naught n into z minus what? N, okay. So now here, if you have a function like this, the Z transform, okay, here is going to be what? Z over what? Z minus what? E j omega naught what? N into what? Mod what? Z. Okay, mod Z is greater than what? 1. Okay, so basically, this is what you can get over here too. Okay, so having done this, I think we have finished solving these questions. Thank you so much. See you in the next class.